LCD comes into adding and subtracting rational expressions, and it also comes into solving rational equations. Here we have an example of a rational expression and an example of a rational equation. The best way to tell which is which is that the equation always has an equal sign somewhere in it. And with an equation, what we're generally going for is a solution set as our final answer. That's going to be a value or a set of values that satisfy the equation. So this will be something like x equals ... or it could be something in roster notation or set builder notation, a list of values that satisfy the equation. When we're adding and subtracting rational expressions, on the other hand, our final answer is a rational expression, and in many cases it still has the LCD in the denominator. So the only case where it would not still have a denominator is if in the very last step maybe that denominator were to cancel out completely with some factors in the numerator. But as a general rule, right up until the end, and usually all the way up to the final answer, your expression still has a denominator in it. To contrast that with what we do with equations, we use that LCD to actually clear the denominators, so after the very first step, there is no denominator left. We are working with something that has an equal sign, and we're able to clear the denominators because of the fact that we can do a balanced operation on both sides of the equation, right? I can take this side of the equation and I can take this side of the equation, and as long as I'm multiplying them by the same expression, it's okay to go ahead and just multiply that LCD, and that clears the denominators. There are no two sides of an expression to do that to. So we can't get rid of the LCD without changing this, or rather we can't get rid of our denominators using the LCD without actually changing this to a different expression. If I multiply this through by the LCD, I have most definitely changed it to a different expression. So make sure anytime you are clearing denominators, you have an equation so that it makes sense to be doing a balanced operation on both sides of that equation. So now I'm going to give us a little bit more room to work with and go ahead and work each of these problems through until the end. Looking at this expression, I can see that I have denominators x minus 2, x, and x squared minus 2x, which can be factored as x times x minus 2. So I certainly do start by factoring all of my denominators and then finding my LCD. My LCD in this case is x times x minus 2. Now, since this is an expression, I do not clear the denominators. I instead want to look at each rational term and figure out what is missing from its denominator and modify it so that it has the whole LCD. 4 over x minus 2 is missing a factor of x in its denominator, so I am going to multiply the top and bottom of this by x. Remember that we are multiplying by a ratio equal to 1, and that's why it is not changing the expression, it is only changing the form in which the expression is written. 3 over x has a denominator of x. In order to get the whole LCD in the denominator, I also need a factor of x minus 2, so I will multiply this by x minus 2 over x minus 2. Finally, my last factor, 1 over, it's always best to leave these denominators factored, x times x minus 2 already has my whole LCD, so I don't need to modify it at all. So now I'm ready to go ahead and combine. I have the same denominator in all three terms. And I can write this first one as 4x over the LCD minus 3 times x minus 2 over the LCD minus 1 over the LCD. And when I put these all over a single denominator, that's going to look like, again, I prefer to leave the distributive property until the next step because we tend to do this correctly when it's all written in line, much better than we do if we try to distribute when signs are more removed from the terms that they apply to. So that means I would wait until this step right here before distributing into the x minus 2 because I want to make sure that I bring the 3 and the minus sign in front of it. If we do it at this step here, it's really common for this minus sign to get left out of the second term. Sometimes it will only show up in the first term and it doesn't get distributed because it's not so clear the way the expression is written here. Okay, so in my next step I then have 4x minus 3x plus 6 minus 1 all over the LCD, and combining like terms, 4x minus 3x and plus 6 minus 1, that becomes x plus 5, and right now is the best time to put that LCD back into my answer, x times x minus 2. I see that there aren't any common factors, so I will go ahead and box this as my final answer. We can compare this now to the process that we follow for an equation. Again, I start by finding the LCD, and again I want all of my denominators factored in order to do that. We've already factored this denominator as x times x minus 2. But this time, instead of building these up to have a common denominator, I'm just going to multiply that LCD by both sides of the equation and eliminate all of the denominators so that x times x minus 2 gets actually multiplied by 4 over x minus 2 minus 3 over x. And over here on the right-hand side also, it gets multiplied by this 1 over x times x minus 2. So that after doing this, on the right we can see that both factors just cancel out completely and all I have remaining is 1. On the left-hand side, I can see that the cancellation is a little more individual. From this first term, the x minus 2 cancels, and I have remaining 4 from the numerator and x from the LCD. In my second term, I can see that the factor of x is what cancels, and I have remaining 3 from the numerator and x minus 2 from the LCD. Over here on the right, as I mentioned already, all we have remaining is 1. So this is now an equation without denominators. I'm ready to go ahead and distribute this 3 into my parentheses to get 4x minus 3x plus 6 equals 1. 4x minus 3x, those terms can be combined to get me x plus 6 equals 1, and then I would subtract 6 from both sides to get x equals negative 5. I would of course check this against the domain, as I'm always supposed to do with equations. The domain in this case is that x cannot be 0 and x cannot be 2. I can always get the domain straight from the LCD. Since negative 5 is in the domain, I can go ahead and accept that as my solution. And if preferred, I can write this using roster notation listing the solution set as being just the value -5. Just to compare these two processes and answers side by side now, let's look at an abbreviated form of what we did. For the expression, we had to modify each rational term to have that LCD as its denominator. So we can see that we still have a denominator in our final answer. And that denominator is the LCD, unless maybe a factor of that LCD is to cancel in the last step, which it did not here. Our final answer is a rational expression. It is not x equals and then some values, right? So this whole thing is still a rational expression. If we look at the equation, this started out with an equals sign in it, and when I'm done, there is still an equals sign in it. We're saying that x is equal to a number. So my final answer here is a solution set. It should be a set of x values which we can express as x equals, or which we can express using some sort of set notation listing the values that are in the solution set. In this process, we used the LCD to clear the denominators, so we can see that after this step that we show right here, there will be no denominators left. We get this all the way down to one level so that we can finish the process of solving the equation.